Hello friends and welcome to Wednesday, April 29th. This is AP Statistics. Today I'm going to go over prompts 3 and 4 from the 2019 free response questions, and I would like you to verify with your work that you got them right and you showed the appropriate work for it. Number 3 gave you a two-way table that showed you the responses or the response rates of men and women who said they never, sometimes, or always take medication as prescribed. And the questions were obviously probability questions. So A.I, the first one, it asked you for the probability of randomly finding a person from this population who both never takes medication correctly and is a woman. So they're looking for the probability of finding N intersect W. And that's just the place where you see the two sets intersect. 0.0636, that's all you have to do for this problem, part 1. For part 2 of A, it asked you to find the probability of finding either a person who never takes medication correctly or is a woman. And that's the union of N and, not M, N and W. All right. How do we find the union? Well, that's the sum of the two events' probabilities minus their intersection. Well, that's 0.12 plus 0.53 minus 0.0636, which is 0.5864. Showing the math is actually an important part of getting the full credit on these open-ended prompts. So you would want to show this. And A, part 3, asked you about the probability of finding someone who never takes their medication correctly, given it's a woman. So that's probability of N given W. The given, as you hopefully remember, changes your sample space, your denominator. So we're looking at given it's a woman, and that was the denominator of 0.53 because there were 53% of the respondents were women. What's the probability of not having taken the medication correctly? That's 0.0636 as a numerator. So we get 0.12 as our result. All right, that's the probability of not finding a person, finding a person who never takes the meds correctly, given we found a woman. All right, part B asked if they're independent. The events don't take your meds on time or correctly, and being a woman. Are they independent? There are 3 ways to verify this. The first way is just using the information we've already found. If the probability of finding a person who doesn't take meds on time or correctly is the same as the probability of finding a person who doesn't take their meds correctly, given it's a woman, we would have independence. We could also do P of W equals P of W given N. It's the same approach, but we already have P of N given W. So P of N, well, that's just the probability of finding a person who doesn't take their meds correctly. That's 0.12. And we found in part 3 of A, P of N given W is also 0.12. They are equal. So the answer is yes, they're independent events. Okay? They are independent events, which means finding a woman in the group does not increase or decrease the probability of finding a person who doesn't take their meds correctly. Gender has no impact, in this case, on the probability of taking your medication correctly. You could also have done the what I said before, P of W equals P of W given N. You would have gotten 0.53 equals 0.0636 over 0.12, which is 0.53. So that would have worked as well. Finally, remember, we also had a way to tell if 2 events are independent. If their product is equal to their intersection, they're also independent. So if P of N times P of W is equal to P of N intersect W, that also would have proven independence. That would have been 0.12 times 0.53 has to equal 0.0636. It does. So any of those ways would have proven the independence of those 2 events. Now the last part, part C, goes off the pattern we've been on, because it asks you to find the probability of choosing 5 people and having at least 4 of them fit the criteria of always taking their meds on time. I think that was the criteria. So they tell you the probability is 0.54, which we also could have seen from the two-way table. But when you're looking at the probability of success or failure, taking your meds always on time or not taking your meds always correctly, this is binomial. This has shifted gears. So we have to use the binomial rule. Now, when it says at least 4 people of the 5, we ask ourselves the questions. Well, we know it's binomial because there's success and failure. We know it's independent events because it said so in the prompt that they're independent events. So the question is it the right side or the left side of the curve? Well, at least 4 is the right side of the curve. We always use the complement rule for the right side of the curve. So it's 1 minus binom CDF. The inputs are trials. There's 5 trials. The probability of success, which is 0.54. And for the right side of the curve, the biggest value, that would be a failure. What's the biggest number that is not at least 4? 3. This is going to give us the answer of 0.2415. And that is the correct solution to the problem. Please understand, open-ended questions want you to explain your answers where possible, all right? On the actual exam, there's only 2 questions you have to answer, and 45 minutes to do so. You should put your all into explaining yourself. This is called calculator speak, and it's not really worth full credit on the AP exam. So you'd want to say what we just said. It's a binomial experiment because we have success and failure. We have independence between trials. So it's the right side of the curve. Sketch your normal curve if you want to. And you could say out of 5 trials, n, the probability of success each time 0.54, p. We're looking for the probability of at least 4 successes. So it is going to be subtracted from 100%, all the values that lead up to and include 3. These are just ways to get the points. And then, of course, explain your answer. There's a 24.15% chance that of 5 people chosen at random, at least 4 of them always take their medication as prescribed. Okay, great. Moving on to prompt number 4. Prompt number 4 asked us to run a test. So obviously we have to correctly identify the test, and we have to show that we verified conditions, and we have our little organizer. So we have the years 2014 and 2017, and we have this fungicide that kills the kochia plant that turns into tumbleweed in the desert. We don't like tumbleweed. It draws the nutrients out that the farmers in the region would like to keep in their actual crops. So they spray this fungicide called glyphosate. Doesn't matter. It's just a story. I mean, it's a true story. But again, it's the concept that matters. The question is, has the kochia plant gained resistance to the fungicide glyphosate? Well, if it has, we would have seen a higher resistance rate as time wears on. They tell you that in 2014, we have 61 plants, that's our N, and 0.197, or 19.7%, were resistant to glyphosate. And in 2017, out of 52 plants, we had 0.385, 38.5% were resistant to glyphosate. Okay, well, we're setting up our organizer. Obviously, in case it's important, we can always identify Q for both as well. If P was 0.197, Q was 0.803, and 0.615. And X, which we know we always will use in these kinds of problems, is the number of plants that the 19.7% and the 38.5% point to. I'm going to keep it decimal based, even though obviously you can't have a decimal value. They gave me 19.7%. That's 12.017 plants. And they gave me 38.5%, so that's 20.02 plants. It does not hurt to keep it decimal. You don't have to round it. I mean, it might be easier for you, but if we don't round it, we're actually using the values we've been given correctly. All right, now, I also know that I have to verify my conditions. So remember what we had done? We just kind of continued this little organizer to do so. So the first condition, do we have an SRS from both samples? It does say that a random sample was taken in both. So given and given the 10% rule. Well, I sampled 61 plants from 2014. Are there at least 610 possible kochia plants or tumbleweeds or whatever we sampled in the desert? Yeah, that's a safe assumption. And in 2017, are there at least 520? Well, if there were at least 610 in 2014, there should be at least 520 in 2017. It's not a stretch to say that. And we also have the conditions that NP and NQ are at least 10. Point of interest, when you look at the rubric, which I'll send when we're all done with this 6 problems, you'll notice that for the P and the Q, they're actually using the P hat combined and the Q hat combined. Now that's a different approach. We haven't seen that before. Our text didn't address that being a plausible approach. Obviously, apparently it is, but it won't be wrong to do what we're about to do. Anyway, NP is the number of plants that showed resistance. That was 12.017. So NQ are the other plants in the sample, 48.983. In 2017, we saw 20.02, which means we have 31.98 that were not resistant. And that's all of the information that we need to set up right now. So clearly we have a 2-proportion z-test for mean difference. Understand that, and maybe even write that down, because it never hurts to state the test. All right, so I'm going to say a 2-proportion z-test, because we're stating what it is we're about to do. It doesn't hurt to say that. Now, in a 2-proportion z-test, we understand we need statements. We also need to identify our alpha, but we need to find the p hat combined and q hat combined to find the z-score, if we recall that. The p hat combined is equal to the successes or the resistance in the first one, so 12.017, plus the resistance in the second sample, 20.02, divided by the sum of their sample sizes, 61 plus 52. So the p hat combined in this problem is 0.2835. So the q hat combined is 1 minus 0.2835. So that value is going to be 0.7165. We need these values because in order to find the z-score for the mean difference, we have to find those numbers. They go under the radical, as you'll see in a minute. All right, one more thing before I erase for lack of space. Our statements. Remember, the null in these 2 sample problems are almost always that there's no difference between the 2 samples. So I'll say P sub D. If you want, you could write sub 2014 minus 2017. Doesn't matter. But the difference being 0 means that there's no difference between the 2 years. That's generally the null condition. Now understand that if, as suggested in the problem, the resistance has increased, the plants have become more and more resistant to the fungicide, I'm going to see a larger value here in 2017 than I saw in 2014. And if I'm subtracting in order, 2014 minus 2017, a smaller number minus a larger number is a negative number. So less than 0 should be my alternate statement here. And we also have an alpha given to us of 5%. Okay, so we have to actually find our z-score in order to find the probability of the sample difference being blah, 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 blah. So let's do that now. Everyone have what they need? Good, hopefully you've written it down. So If there is a statistically significant difference, we'll see it in the z-score and the p-value that we find from that. The z-score for the difference is the first proportion, 0.197, minus the second proportion, 0.385, divided by, oh, and by the way, if you heard or saw 19.7% and you just wrote down 19.7, you're going to get some crazy answers here. Understand, percents have to be turned into decimals. Never make that mistake. Now, the denominator of the z-score equation is p hat combined, q hat combined over n sub 1 plus p hat combined, q hat combined over n sub 2. So 0.2835 times 0.7165 over 61 plus the same numerator, 0.2835 times 0.7165 over 52. That's going to give me a z-score of negative 2.21. Negative 2.21004, blah, blah, blah. Just rounds off to 2 decimals this time. We remember that if we have a 0 difference, as the null is suggesting, a z-score of negative 2.21 is somewhere down here. We also remember that the shading goes in the direction of the alternate symbol, which was less than. So I'm going to shade down. And now I have to find the area under the curve that I just shaded. So because we've normalized, because our conditions have been met, we're going to use normal CDF. The lower bound is a negative infinite bound, and it goes up to negative 2.21, with 0 and 1 as the mean and standard deviation because we normalized the distribution. That gives me a p-value of 0.0136. Okay, so my p-value of 0.0136 is less than my 5% alpha. So what do you do when the p-value is less than alpha? We are able to reject the null. Reject the null. That there's no difference. Okay? Now, don't stop there. Some of you guys on your responses are stopping at reject the null or fail to reject the null. You have to have some kind of inference. What does it mean? All right, well, if I'm rejecting that there's no difference, that means that my evidence is strong enough. Stop the rattling. My evidence is strong enough to show that the Kochia plants are becoming more resistant to the fungicide. Okay? You could write more if you'd like. For instance, if the Kochia plants are becoming more resistant to the fungicide glyphosate, the farmers in the region might need to switch to a different fungicide because the plants are going to turn into tumbleweeds more and more and drain their resources. This is the purpose in running the test. Don't stop short of actually giving inference. The purpose was the inference. If you stop short of actually explaining your answer, you're kind of, you're hurting yourself because you're not going to get the fullest possible points. They grade holistically. So maybe you made a little error here or there, you rounded wrong here or there. If you explain it correctly, you earn points back. They want to see that you can apply the meaning. So don't stop short. Now, what I'd like you to do, as I already mentioned, is move on with the rest of these 2 prompts, 5 and 6. Please submit the prompts to me before I submit the answers to you. Some of you guys are kind of straddling the line. Some of you guys are sending me the answers 3 hours after I post the video. probably not the best application of a homework assignment. So please get it done before I post. I know I have these things scheduled to drop at 7:45 in the morning, and I'm giving you until the next day when they come out. So it's a 24-hour cycle to do 2 questions. I know you got other things to do. Trust me, I understand. Things aren't like they were before, but try to get them done before I actually send the answers to you. That's all I've got for today. Hopefully you can have a great day. Bye.